Hi everyone, this will be a short workshop on how to implement a dictionary in C#, and you'll see that it's not that complicated. So let's create a new project, and then I'll try to explain what is it that we'll be doing. If you haven't watched the lecture, I think it was number 1 of this course. I'll just revise a little bit on the dictionary. So this is gonna be dictionary, or just, I'll just put all of them here. Zariba workshop. Okay. I'll need to pause here for a quick second to fix something on my tablet. So just a second. Alright, so we'll be implementing a dictionary with the help of a hash table, and one of the methods that we discussed in the first lecture was with the use of a linked list. So it was like we had something like an array where we have some indices here, 0, 1, 2, 3, 4, 5, and so on. And as soon as we wanted to add an element, it would have a unique hash code, okay, which we saw was some like big number, so 1, 5, 2, 3, something big, okay. And then we said, well, how would you implement that? Well, you have to get the remainder of division, in this case by 6, by the size or by the length of the array. So in this case, this divided by 6, I have no idea what the remainder will be. I don't know, maybe 1 or 3, I don't know, just some value, and then you will put it in the corresponding cell. Okay, but what happens if two elements give the same hash code once one of these here? Well, they can't give the same hash code, but they can point to the same element in this array. So then this element would have to go in the same place, right? And we discussed that there are a couple of ways to fix this or go around this. So one of them, well, just put it in the next cell, all right, or the one after that if it's taken, and so on. But what we'll be doing today, which I believe is simpler, we'll just have each of these elements here. There will be just a linked list. Okay, so in this case, imagine that you have something like a mini list inside this big list here, and in here we'll be storing values if we have some collisions in our hashing. Okay, another thing that we should point out, what's gonna happen when we run out of space in the big array? What is it that we have to do? Okay, so we have to increase the size, and one more thing, we have to rehash everything, because now we will get new indices, and it's gonna mess up the order and everything. Okay, so that's pretty much it. So let's try to create the class. So I'll click on here, add class, and I'll just call it dict. I think that's fine. Alright, so let's make that public here. And okay, so first up we'll need some constant, which is gonna be initial size equals 16. All right, and we'll need our way of storing all of the values. So we'll be using a linked list of key value pair k comma v. I think that's that, and we'll need to have an array of that as well. So and that will be values. I'll explain everything in a second. So to make use of this, key and k and v, which is going to be our generic type. In here we would also have to say public dict k comma v, and that's gonna implement IEnumerable of key value pair of k v. Alright, so we have a built-in, let me just implement that so that, okay, so we will have, so our dictionary here is gonna implement the IEnumerable interface, which means that we'll be able to for each our dictionary, but we'll implement that. I think it'll be one of the last things that we implement. All right, so is it sort of clear? So we'll have a linked list of key value pairs, and that will be an array. So what I'm saying here is that we'll have this array, okay, and each element in the array will be a linked list. Okay, so the top thing is an array, and every element, I'll put it in green, will be a linked list, and then every single element in the linked list will have to be, as we discussed, it has to be a key value pair. But since we already have this built in, there is no reason to write it out again. So yeah, is it clear what this thing is? This is just where we'll store our values. Okay, so let's have a constructor, which, if I remember, if I do this, it will generate it automatically for me. Let me check if there is something that we need to fix. Actually, let's make it here. So this dot values, as soon as we want to initialize our dictionary, we want to say this dot values equals new linked list key value pair, and then we want to say this is of size, initial size. Okay, and this is something that will be changing. So as soon as our array is sort of filled in, we would like to increase the size and rehash all of the values that we have in it. Okay, a couple of public properties. So we'll have public int, can I just write that? So prop, the property is going to be count, and it will have a get and private set. And one more, we'll have public int capacity, which I have to write out. So it's going to be get, and inside we'll have return this dot values dot length. Okay, so the count is the number of elements. We have to set it, increase it once we add elements and so on. The capacity is going to show how big is our array in this case here. Okay, what else do we have? Okay, so let's write out the methods that we have to implement, and we'll do those in a bit. So public void add, and we would like to have k key and v value. Okay, what else do we have? So we would like to have a find method. So this will be public. It will have to return the value. Okay, so we search by key. So we would have to be public v find k key. So we find an element by value, and then we return it if we have it. So return. Yeah, let's implement that later. Okay. What else do we have? Public bool contains key, k key, and what else do we have? So private int hash key. So instead of just write, so every time when we have to hash and rehash, it would be better to just have a function that would do this for us, instead of having to writing it out and repeating code. So this why this one is private, because no one needs to know how we do our hashing. Okay, and another private one. So private void resize and re-add values, which is probably going to be the most interesting method. Okay, anything else? And then we have these two, which are going to help us just for each our thing. So is it clear what we have to do? Okay, so let's start. Which one would be easiest to do? The hashing, but I don't want to start with it, so let's start from the add here. And I don't think it's even that complicated. Okay, so what's the first thing that we have to do once we want to add an element to our values array? What's the first thing that we have to do? So let's say that someone gives you an element and says, okay, you have to place this in the dictionary. What's the first thing that you have to do? Hash it. Okay, good. So someone's paying attention. So var hash equals this dot hash key of key, and it turns out that we have to implement this now. So let's do it. So how did we say we were hashing elements? Okay, I just mentioned this at the beginning of the lecture. So we have to say var hash equals, so we need to have the hash of the key, so key dot get hash code, and then what is it that we want to do with this whole thing? Percentage what? So what was that? We had a property for it, this dot capacity. Is there a problem? So yeah, this is fine. Is there a problem though that we need to take care of? So what was get hash code? What kind of values did it give? Do we not remember? Okay, integers, but what kind? So yeah, integers, but they can be also negative. Okay, so we need to convert them into a positive number. So it will be math.apps key.get hash code percentage this dot capacity. Okay, and now we are fine. So this is the hash, and we have to return it. So return hash. Okay, we are good to go with the hash in here. Let's see what we have to do next. Okay, so we have the hash, and now we can access and we can see whether there is already a value in our array. So let's say that we have the hash, and it turns out that it's something like 1. So this is 0, 1. So then we have to check, well, do we already have values here? Okay, if not, we have to create a new linked list at this place. If we do have, then we have to, re-add it to the linked list. So that's pretty much what we need to do. So if what is that? If this dot values of hash equals null, then we would like to say this dot values of hash equals new linked list of key value pair of k and v, this way. Okay, so we did that. I have no idea what this line of code does, but let me just write it out and maybe it will click. So var key exists already equals this dot values of hash dot any p dot key dot equals key. Okay, yeah, so we need this to see if someone wants to add an element which has the same key twice. So let's say that we want to add element something like key 1 and value, I don't know, let's just do it this way, 1, and then let's say that the value here is peso, and then add 1 gosho. Okay, so this operation will not be allowed, right? In our dictionary we cannot have the same key more than once. So yeah, this line checks whether we already have the key somewhere. So this way it says any. Okay, and then we have to check and throw an exception if the key already exists. So if key exists already, throw new, what kind of error do you think? Operation exception, invalid operation, I think is going to be the best. Key already exists. You cannot add two elements with the same key, I think is a good descriptive message. Okay, and then what is it that we have to do? We have to create the key value pair, and we have to put it inside the linked list of the array. Okay, so now we have the array. We've checked whether we have to create a new linked list at the spot. We checked our keys, and now we just have to add it in the corresponding place. Okay, so this is going to be done. So var pair equals new key value pair of kv. Let me just find it. Okay, key and then value. Okay, so now we create the element, and now we have to say this dot values of hash dot, how would you add now the element at the specific linked list? Add last. Okay, and then we want to say pair of pair, and this dot count plus plus, and that's pretty much our method. There is one more thing to add, but I'll let you think it through just a little bit. You want to? Okay, so yeah, this is the whole method. So there is one more thing to be done, and can a problem arise when we add elements? So this is now gonna work, but it's gonna work up to a point. So is there anything that we need to do more in this method? Okay, check if we should resize. Okay, so let's do this in the following way. So if this dot count bigger than or equal this dot capacity, so this cannot happen, I think, but if we multiply this by a constant, we'll see, well, if our array is sort of filled in, like most of the cells are, filled in, then we would like to resize. It's not necessary to go, to the complete fullness of our array. It's not necessary to get 16 elements in order to resize. We can do it at, let's say, I think that's 12 elements or something, and then we can resize, and we will have this method. So this dot resize and re-add values. Okay, which is going to be somewhere down here, and this is I think a bit more interesting method that we'll have to write. Okay, so let's see, what is it that we have to do here? So the first thing is we have to cache the values, or keep the values, like store them, so that we don't lose them. Then we have to resize. Yeah, it's not there. I don't know why I'm writing it here, so it's there. Okay, so resize, and then we have to add the values again. Okay, so how do we store the values? We just make a variable, so it's going to be var cached values equals this dot values. Okay, how do we resize? Well, we just say this dot values equals new linked list key value pair of kv, and we would like to double the size of the array, so 2 times this dot capacity. Okay, and then we have to add the values. Okay, so in our add function, which we already have, and this is what we will use, in here we increase the count. So I suggest that we make it null, 0, and then every time when we add the elements that we've already stored, it's gonna increment to the specified number of elements. Yes. So the question is here, do we have to? This is a very good question. So the question is here when we say cached values equals this dot values, and then we change this dot values, shouldn't we say something like dot clone? Okay. Can someone answer this? I would like you to think about this, because this is an interesting question in the specific case. So I'll pause and I'll let everyone think for a bit before answering. Okay, so the answer here is, and let's do some revision before that. If we have the case where I do var array1 equals new array, and we say var array2 equals array1, and then if I change the value of the first array, let's say array of 2 equals 7, which is some different value from what we had, then what's gonna happen is, I'm sorry, this is array1. So what's gonna happen is that array2 is gonna change also the same way as array1 did, and this is because the array is a pointer type. So in the memory, let's say that this is the RAM. When we initialize it with this line, it saves some space for our array here, and it says, well, array1 is now going to point here. Okay, once we say this, we don't actually create a new array, we just say, well, array2 is going to have the same pointer. So when we change the first array, we actually change this place in the RAM where both of these arrays point at. Okay, but what we do here is something a little bit different. So we say we already have in the memory this dot values, so somewhere around here this will be values. Okay, and we say, well, let's make a new array which is going to point to the same space in the memory. So this is going to be cached values. This is horrible. Cached values, and what we do is we say, well, this dot values is now a new array, which means that it's no longer going to be here. It's going to be creating for itself a new place in the memory where we are going to store this dot values. But the original one, the cached values, they still point in the previous place of the memory. Okay, but if you are not sure about this, you can always say .clone, right? And it's going to create a new instance, and that's not going to be a problem. Okay, normally C# should be smart enough to know if we do it with .clone and then with the second line here, C# should be smart enough to know that we've left the original array, and now we'll have like 3 spaces in the RAM. So this is going to be the this will be this dot values here. Okay, we create a new one for the cached values, and then we say, well, we are no longer gonna have this. We would like to create a new one here, and now This element doesn't have a pointer, which means that C# should be smart enough to know to clean it. Okay. But in JavaScript you can never be sure whether that's what's going on. So when we had to optimize our games in Phaser, it turned out that JavaScript didn't clean anything, or Phaser didn't clean anything that is our own class. So if you create your own class, which does not extend some sort of phaser.sprite or something, then you have to clean up every variable that you use, which is something that we didn't do in our butcher game, but it can easily be done. Okay, otherwise you get memory leaks, which are kind of harsh when you put them on mobile. Your games are gonna crash. Okay, so this.count equals 0. Okay, and then we have to say, we just have to go through all of the elements and re-add the values. So for each var collection in cached values, then we want to say for each, I think this will be var value in collection, this dot add value dot key and value dot value. And I think that's all that we have to do here. Okay, while we're at it, let's do these two methods, since they're very similar to that kind of thing. So we would like to go to for each our dictionary, which is gonna happen in a very similar manner. I think we've written this a couple of times, but the easiest way, well, here you just say return this dot get enumerator, which is the method above, and here we just need to implement how would we like to return the values or go through the values. So this is going to be for each var collection in this dot values. Okay, we have to go through each linked list of our array of linked lists, and then we want to say for each, maybe only if it's not null. So if collection is not null, collection what? Up here is with two T's. Okay. If collection is not null, then we want to do another for each var value in collection, and we want to say return value. Or is there something more specific that we have to say here in order for it to work? There was something specific when we were yields. Okay, so yields return value. Where? Up here. Well, if it's if this one specifically is empty in the other, okay, here. Okay, so the question is, shouldn't we do the same thing up here? I guess so. Okay, so let's do that. What was the control KT? No. Control Alt T? No. What was that? Control KS? Control KS. Okay. So we have to put this inside an if, and in this if we would like to say collection is not null. Yes. Okay. I guess that's that. What does yield do? Okay, so if we just say return value, we are gonna exit the method, right? What yield does is, we return the value, but we still go through the loop where we are. So if you're like in a for loop, where did I press enter? So if you're like in a for loop for I from 0 to, let's say, 10, and if you say here return once, it's gonna exit the method, but if you say yield return, it's gonna return the value back, but it's gonna remember that, you know, I was 0, then it's 1, then it's 2, then it's 3, so it kind of remembers where you are at in your calculation. But you know, this thing is only used when you want to implement pretty much this method. I haven't seen it anywhere else, and it kind of makes sense to be used here, because this is what you want to do. You want to return some specific values of your choice to the user, which is going to do a for each loop on your dictionary. So yeah, we had something similar for the graphs. There was a bit more necessary because we didn't use pretty much anything built in. We did everything from scratch. So we didn't use something like you know, lists of stuff. You know, we just implemented most of it from scratch. And there, if someone says, well, graph dot for each, then you would need, you know, specific elements which are your own that you've created to be brought back to the user. Okay, so a couple of more methods that need to be done. They're pretty short. So we have something like find. Okay, find by key. So this is going to be quite simple. Var hash equals hash key, or this dot hash key of key. Okay, so this is what's going to help us to find the element. So if this dot values of hash equals null, return, well, we would return false, meaning that we haven't found it. Okay, right? So if we don't have anything, like if the linked list at this place is null, which means that we don't have the element, you know, we would like to return sort of like false, meaning we haven't found it. But we don't want to do that. We want to return some value in v. So how would you say this is a bit tricky? I don't know if we've done it, but it kind of makes sense. So let's say that v is an integer. What value would you like to return, or if it's a string or something? Okay, so you would like to return no, but this could break some of the logic, so I would just return default v. Okay, so this is the default value for every type. Like if it's a string, it's going to be the empty string. You know, if it's Boolean, I think it's going to be false or something. So yeah, just the default one. But you can also return null, but I don't think it may break your logic. So if you like to find an element and do something with it and so on, if it's null and say you want to take some property of it once you found it, then this may cause a problem. Yeah, throw an exception. Okay, else var collection equals this dot values of hash, and we want to return the element. So we want to return collection dot first p dot key dot equals key dot value. Okay, so this is kind of a weird line, or not that much, because normally these are easy to read once you get what's going on. So so yeah, if it's not empty, means that we'll be getting to here, and we take our linked list and we say, well, find me the first element p such that the key of p equals the key that we want to find. Okay, and then we want to just return the value of that element that we found. Okay, so it took me about 2 minutes to come up with this line of code, but then it reads all right, I think. Okay, and this is very similar. So var hash equals hash key of key, and if this dot values of hash is null, then we want to say return false. Otherwise, var collection equals this dot values of hash, and then we want to say return collection dot any pair dot key dot equals key. Okay, so if any element has the same key, we just return true, and that's it. Okay, let me see if there is anything else that we haven't done here. I think that's pretty much it. Okay, let's test it. Okay, so let's create a dictionary. For our dictionary equals new dict. What kind of values do you want? I'm fine with anything. Okay, int string. Okay, and let's add some elements. So our dictionary dot add, or let's do it in a loop. So for I from 0 to, let's say, 10, let's add 10 elements, and we will say our dictionary dot add, and we'll add so I here, or maybe I plus 1, and then this will be bunny plus I plus 1 dot to string. Alright, and let's see. We can print it first. So our dictionary, or was it like for each first? Yeah, too much JavaScript in the past couple of months. So for each var bunny in our dictionary, let's say that we want to print key k, and then value, and here we want to say bunny dot key, bunny dot value. Alright, let's see if that's gonna work. I guess I ran it for the first time, so it's taking a while. Alright, so it looks like it works. We're good. Alright, so let's do something else. Let's try now here to add our dictionary dot add, and let's say to bunny 5. We should get an exception. Okay, key already exists and so on. That's good. So let me comment that. The line below throws an exception. Okay, what else can we do? We can test some of the other methods, right? So we have find, and what was the other one? Okay, so we have find and contains. Okay, so find our dictionary dot find. Let's say that we want to find bunny number 5, and then we want to say it did return the value. Do we have to say value here, or it just returns it straight away? So let's see. Okay, bunny 5 here. We're good. What else? What else can we test? We can test What's gonna happen if here I give something Control C, Control V, something that we do not have, something like 16. It's just gonna give the empty string, so we haven't found it. Or you can return a message or something, or return -1 in some, let's say, index of works this way, so you can also do like return -1. But I think this is all right. And then we have to test the other method. So our dictionary dot contains. Thank you. Is this the one that we wrote? Contains key is the one that we wrote. Really? Contains. I don't remember. I just wrote contains key. Contains key. Let's say 7. It should be true, and then something like 25, which should be false. True and false. All right. So the point is that these are really fast. Okay. So let's increase that to something like 100,000. And let's make a what was it in? Let's do it with datetime. So var start equals datetime dot now. Let's add 10. Sorry, this is 100,000 elements. And in here, let's just print. So write line equals datetime dot now minus start. Is that gonna work? I hope it does. But we don't want to print them, right? So control case. Oops, what did I do? Control case C, yeah. All right. So but printing takes a lot of time. Okay, and I just don't want to print them, all of them, because there are quite a few of them. The for each, it does, but we'll do that in a second. So okay, so first you saw that it takes half a second to add 100,000 elements, which is very fast. And let's say that we want to find some element. So let's say that we want to find where should I do that? Contains key. Let's do the find here. Var start. Var, or just say start equals datetime dot now, and let's see how long is it gonna take to find the element. Datetime dot now. Minus start, and we can do that in here as well to see how long it takes to go through all of the elements. So let's do that here as well. So start equals datetime dot now, and we'll do it after as well. So datetime dot now minus start. All right, so we should be getting 3 times now. So the first one is adding 100,000 elements. Then we would like to go through all of them, maybe do some operations there, but not print because this takes a lot of time. And finally, we would like to find some element. Let's make it a bit more interesting, something like 7,654. Okay, so it takes half a second to create all of them. It takes 0.03 seconds to go through all of them. So depending on your operations, it may take longer, but it's still pretty fast. Then it takes pretty much the same time to just find a value, which is really fast. Thinking that we have 100,000 elements now, this is pretty fast. What's gonna happen if I add an extra 0? Do you think it's gonna increase by too much? Let's see. Okay, let's wait a bit. Okay, 5 seconds to create all of them, and then finding it takes pretty much the same time, and going through all of them takes not that long as well. So here the problem, or it's being slow because we have to resize every couple of times. So how many times do we resize here for 1 million elements? So around 20 times, 21 times we have to resize, and you know, this takes some time as well. If you try the built-in dictionary, it's a lot faster. This is like 0.9 seconds to add, you know, that many elements, but they do low-level optimizations there that we can't do here, but it's still pretty fast for something that we wrote in about half an hour, I think. Alright, so are there any questions on the code? So this is the code that we wrote. Do you have any questions? Or yeah, question? So it's not really a question, it's like a statement. So if you have a dictionary of int and we return the default one, it should be 0. Yeah, it should be 0. Then if you wanna, yeah, so yeah, I told you this may not be the most correct thing to do, but you can choose to do whatever you want. So you can check if like v is int, then you want to return -1 or something. Just in this case, I think that for, you know, basic operations, the default value will be all right. But here it's kind of hard to decide what you wanna return if you don't have the value, right? So you cannot return 0, you cannot return an empty string, right? What's gonna happen if you have like, what's gonna happen if v is like a bunny, or like some of your own like class, and then you wouldn't know what to return when you have a null, right? You can also do that, okay, but then whoever uses it should know that this method could return null. Okay. We can't do null because v cannot convert null to parameter v because it could be a non-nullable type. Yeah. So this is what I did, and if you can read what's in here, then it says consider using default v's instead. Okay. So that's what I used. Okay, but if you have a better idea, feel free to do that as well. Any other questions? Okay, the next workshop is going to be on quicksort. So yeah.